Okay, so continuing on with section 4.2 on graphing quadratics, hopefully you were able to watch one of the videos about how to use your calculator to create a table for a function. So because I won't be able to put a calculator on the screen, I'm going to talk you through it. So if you've not watched that, stop this and go back and watch that now. So the instructions say graph parabolas using calculator technology. Use the table button on your calculator to graph the quadratic function. Place the vertex in the bold boxes in the center of the table. So what you want to do right now is pause the video and enter the function for number 3 into your calculator until you get the table and can look at it with me. Okay. So hopefully you've got that table in front of you on your calculator. We'll go ahead and answer the question. The function is written in blank form, and so this one is in intercept form because it is factored. All right, so that is an intercept form. Okay, so you know how to use your table, but the important part for a quadratic is that we want to balance our quadratic when we graph it, and we have to graph at least 5 points. So that's why this box in the table right here has been bolded, because we want that to be your vertex. So when you are looking at your table, you are looking for your x values to increase, and then, your y values, as your x values are increasing, you want your y values to increase and then get to a point where they begin to decrease again, or they're going to be decreasing but then turn around at a point where they're going to be increasing again. And so that point where we're turning around is the vertex. Okay, so in this particular case, when you're looking at your table, your flex point, the point where you're going to start turning the graph back around, should be where x is equal to 4. Okay, so where x is equal to 4. So hopefully you are seeing the graph turn when x is equal to 4. All right, so when x is equal to 1, your table value tells you that f of x, or y, is equal to 1. And then we also want to look at the points when x is equal to 3 and when x is equal to 5. And when x is equal to 3, your output should be 0, and when x is equal to 5, your output should also be 0. So this is the pattern where we want to see where it's decreasing, and then at this point we do not have a repeated value for y, and so it moving down, it begins to increase again. Okay, so that is where we see our graph flip, which means we've identified the vertex. Okay, so we need 2 more values in our table. So we want to find values that give us hopefully outputs that fit on our graph and are easy to graph. So take a look at your table and choose a point on the top for the top row and the bottom row of your table. Okay, so the other 2 points I chose were 2, -3, and 6, -3. And then we're just going to go ahead and plot those. So we're going to plot 2, -3, 3, 0, 4, 1, 5, 0, and 6, -3. And we need to connect them. We've got 5 points. We need to connect them, and then we're going to answer these questions about the features of our graph. So the y-intercept is actually not on, it's not in our table, and it's also not on our graph. But if you look at your table, you are looking for when x is equal to 0. Okay, so if you look up here where x is equal to 0 on your table, you can see a y value of -15. And so that is going to be your y-intercept is 0, -15. Remember to write that as an ordered pair. Your x-intercepts, where we're crossing the x-axis, are going to be at 3, 0, and 5, 0. which means that we do have two real roots, two places where it crosses the x-axis. So x is equal to 3 and 5, the set 3 and 5. The axis of symmetry is the vertical line that passes through the vertex, splits the parabola in half. So it is the equation x equals 4. And the vertex is going to be at 4, 1. 4, 1. Which means that our min or our max where this graph maxes out, is going to be at y equals 1. Okay, so hopefully you were able to get your calculator out, figure out how to use a table. You can also use a table in Desmos if your calculator is not available, although I very much encourage learning how to do this, especially before taking the SAT. So you are going to do number 4, okay, and then we're going to take a look at the essential question right now. So what is the quadratic parent function? That one is f of x is equal to x squared. Okay, and then the second question we're answering is, how do you graph a quadratic function? So first, I think you need to find the vertex. Whether you're using technology like your calculator or Desmos, or you are plugging numbers in, you have to find the vertex first. And then so you can use technology. Then to find the coordinates, of 5 points and plot into a parabola. So plot the points. All right, and that is how we graph a quadratic. Okay, so when it comes to reflecting on your learning, tell me about one thing that either went well or was a struggle for this lesson. All right, and make sure when you're answering your question that you are telling me which one you're answering. Something that went well or something that was a struggle for this lesson. All right, that's all. Have a great day. Bye.